All right, math analysis. Here is the last video. This problem's 21 and 23. This will be by far the shortest video. These are fairly easy problems compared to everything else. Okay, so number 21, convert 4, -4 to polar coordinates. Remember, polar coordinates have a radius and an angle. It's a different way of thinking about where a point lies. First thing I'm going to do, though, is just plot this like normal. So 4, -4. Okay, so I want the radius, how far that point is from the origin. I'm just going to build myself a right triangle. We know that's 4, 4. Now, you could use Pythag. 4 squared plus 4 squared equals c squared, but hopefully legs are same. That should trigger that we're talking about a 45 degree, 4, 5, 4, 5. So 4, 5, 4, 5, the answer is about to arrive. Use root 2. So your hypotenuse or radius is 4 root 2. So we got the first part. Now for the angle, it's typically the positive angle. We don't have to do it always the positive, but I'm going to go ahead and do it positive. The positive angle to that point. Since I've got 45s here, I'm counting 1/4, 2/4, 3/4, 4, 5, 6, 7 pi over 4. That's my angle. Oops, not over 6. There you go. And that's all there is to it. And again, this meant go right down. This means rotate and go out from the origin that much. There you go. There's your answer. Number 22, reverse of the process. This is in polar. We want to go to rectangular. Now, I mentioned this in class. I kind of think this is backwards. I like to do the rotation and then out. So pi over 3 would be 2 pi over 6. So 1/6, 2/6. This is a 60-degree reference then. 3 is how far out from the middle. 1, 2, 3. Now it wants the rectangular coordinates. That's a fancy way of saying it wants the legs of this. It wants to know how far we went that way, and then how far we went that way. The typical way you're used to graphing. Go left or right, then go up or down. Again, you could on this use some trig maybe if you wanted, but again, it's a special right triangle. There's a reason for that. We're doing the 3060, so 3060, keep it on the down low, use root 3, use 2 times. For the short leg, remember it's just half the hypotenuse. So that's 3 over 2. To get the long leg, you just multiply the short leg by root 3. So the coordinates of this point in rectangular form would be go right 3/2 and go up 3 root 3 over 2. Again, this is right and up. This is rotate 60 degrees and we'll step out 3 steps, but same thing. There you go. Last problem. Graph this. I'm going to show you how to. Oh, excuse me. Come on back. There we go. I'm going to show you how to graph this the way we did in class. This is a rose. That is the petal length. And if it's an even number, we double it to get the number of petals. So there are 4 petals. Now if you remember with a sine rose, the first petal does not just split the x-axis. That's if it's a cosine. For the sine rose, here's what we had to do. we had to take this stuff and set it equal to pi over 2. And I went through the logic in class of why this is. If you want to know again, come and talk to me. But divide by 2, so dividing by 2 means timesing by a half. I'm solving for theta here. Timesing both sides by a half. So theta equals pi over 4. That tells me that I start my first pedal at pi over 4. Oh, that was actually kind of good. So my first pedal is going to branch out 4 spaces. So 1, 2, 3, 4. I'm assuming I have circles drawing here. And now I've got to split 2 pi into 4 equal parts to get my pedals evenly spaced. So I've got to split 2 pi into 4 equal parts, which means each pedal is going to be pi over 2 from that previous one. So if I add pi over 2 to this, it's going to get me over here. And if you want verification of that, just think, okay, I started at pi over 4. This was pi over 4. So I started at pi over 4. If I add pi over 2, you get common denominators, that'll be 3 pi over 4. So my next pedal is at 3 pi over 4. So again, and then that's out 1, 2, 3, 4, because that was my length. And then, again, it's going to be evenly spaced. So your next 2 are just going to be down here. Going out 4, going out 4, and then you've got your pedals. Terribly drawn, but there they are. Now that's how we did it in class. Again, hey, you've got a fancy calculating device. I showed this in class. We didn't really do it though, but let me show you real quick what we can do here. We can switch to polar form. If you go to mode, first thing you're going to want to be in radians, and on mine, next thing is func for functional. I'm going to go over to pol, P-O-L for polar, and now when I hit my y plots, it's no longer y plots, it's theta plots. And I'll clear that out so we can see me actually typing it in. But I'm typing in, where is it? There it is. I'm typing in r equals 4 sine 2 theta. So it's already r equals 4 sine 2. And now when I hit the variable button that usually gave me an x, it now gives me a theta. And then you can just hit graph. And there's your 4 pedal geometric rows, and these are each going out 4. It's kind of hard to tell, obviously, but they're all going out 4. So that's kind of the shortcut way to do it. All right, that is it for the reviews, the review problems for the calculator OK portion.